Please like, share and subscribe our channel to learn and enjoy our free online educational videos from class nursery to 10. Please click the bell icon to get all new updated videos.
Lesson 2. Is matter around us pure? For a common person, pure means having no adulteration. But for a scientist, all these things are actually mixtures of different substances and hence not pure. For example, milk is actually a mixture of water, fat, proteins, etc. As we look around, we can see that most of the matter around us exists as mixtures of two or more pure components. For example, seawater, minerals, soil, etc. are all mixtures. What is a mixture? Mixtures are constituted by more than one kind of pure form of matter known as a substance. A substance cannot be separated into other kinds of matter by any physical process. We know that dissolved sodium chloride can be separated from water by the physical process of evaporation. However, sodium chloride is itself a substance and cannot be separated by physical process into its chemical constituents. Similarly, sugar is a substance because it contains only one kind of pure matter and its composition is the same throughout. Soft drink and soil are not single substances. Whatever the source of a substance may be, it will always have the same characteristic properties. Therefore, we can say that a mixture contains more than one substance. Types of mixtures. Depending upon the nature of the components that form a mixture, we can have different types of mixtures. A mixture or solution which has a uniform composition throughout. Such mixtures are called homogeneous mixtures or solutions. Examples of such mixtures are salt in water and sugar in water. Mixtures which contain physically distinct parts and have non-uniform compositions are called heterogeneous mixtures. Mixtures of sodium chloride and iron filings, salt and sulfur, and oil and water are examples of heterogeneous mixtures. What is a solution? A solution is a homogeneous mixture of two or more substances. You come across various types of solutions in your daily life. Lemonade, soda water, etc. are all examples of solutions. Usually, we think of a solution as a liquid that contains either a solid, liquid or a gas dissolved in it. But we can also have solid solutions, alloys, and gaseous solutions, air. In a solution, there is homogeneity at the particle level. For example, lemonade tastes the same throughout. This shows that particles of sugar or salt are evenly distributed in the solution. A solution has a solvent and a solute as its components. The component of the solution that dissolves the other component in it, usually the component present in larger amount, is called the solvent. The component of the solution that is dissolved in the solvent, usually present in lesser quantity, is called the solute. Alloys. Alloys are mixtures of two or more metals or a metal and a non-metal and cannot be separated into their components by physical methods. But still, an alloy is considered as a mixture because it shows the properties of its constituents and can have variable composition. For example, brass is a mixture of approximately 30% zinc and 70% copper. A solution of sugar in water is a solid in liquid solution. In this solution, sugar is the solute and water is the solvent. Properties of a solution. A solution is a homogeneous mixture. The particles of a solution are smaller than 1 nm, 10-9 meter in diameter, so they cannot be seen by naked eyes. Because of very small particle size, they do not scatter a beam of light passing through the solution, so the path of light is not visible in a solution. The solute particles cannot be separated from the mixture by the process of filtration. The solute particles do not settle down when left undisturbed, that is, a solution is stable. Concentration of a solution. In a solution, the relative proportion of the solute and solvent can be varied. Depending upon the amount of solute present in a solution, it can be called a dilute, concentrated, or a saturated solution. Dilute and concentrated are comparative terms. At any particular temperature, a solution that has dissolved as much solute as it is capable of dissolving is said to be a saturated solution. In other words, when no more solute can be dissolved in a solution at a given temperature, it is called a saturated solution. The amount of the solute present in the saturated solution at this temperature is called its solubility. If the amount of solute contained in a solution is less than the saturation level, it is called an unsaturated solution. Different substances in a given solvent have different solubilities at the same temperature. The concentration of a solution is the amount of solute present in a given amount, mass or volume of solution, or the amount of solute dissolved in a given mass or volume of solvent. Concentration of solution equal to amount of solute or amount of solution, or amount of solute, amount of solvent. There are various ways of expressing the concentration of a solution, but here we will learn only two methods. 1. Mass by mass percentage of a solution equal to mass of solute upon mass of solution multiplied by 100. 2. Mass by volume percentage of a solution equal to mass of solute upon volume of solution multiplied by 100. Example: a solute contains 40 gram of common salt in 320 gram of water. Calculate the concentration in terms of mass by mass percentage of the solution. Solution: mass of solute, salt, equal to 40 gram. Mass of solvent, water, equal to 320 gram. We know mass of solution equal to mass of solute plus mass of solvent equal to 40 gram plus 320 gram equal to 360 gram. Mass percentage of solution equal to mass of solute upon mass of solution into 100 equal to 40 upon 360 into 100 equal to 11.1%. Non-homogeneous systems in which solids are dispersed in liquids are called suspensions. A suspension is a heterogeneous mixture in which the solute particles do not dissolve but remain suspended throughout the bulk of the medium. Particles of a suspension are visible to the naked eye. Properties of a suspension. Suspension is a heterogeneous mixture. The particles of a suspension can be seen by the naked eye. The particles of a suspension scatter a beam of light passing through it and make its path visible. The solute particles settle down when a suspension is left undisturbed, that is, a suspension is unstable. They can be separated from the mixture by the process of filtration. When the particles settle down, the suspension breaks and it does not scatter light anymore. What is a colloidal solution? The particles of a colloid are uniformly spread throughout the solution. Due to the relatively smaller size of particles as compared to that of a suspension, the mixture appears to be homogeneous. But actually, a colloidal solution is a heterogeneous mixture, for example, milk. Because of the small size of colloidal particles, we cannot see them with naked eyes. But these particles can easily scatter a beam of visible light. This scattering of a beam of light is called the Tindle Effect, after the name of the scientist who discovered this effect. Tindle Effect can also be observed when a fine beam of light enters a room through a small hole. This happens due to the scattering of light by the particles of dust and smoke in the air. Properties of a colloid. A colloid is a heterogeneous mixture. The size of particles of a colloid is too small to be individually seen by naked eyes. Colloids are big enough to scatter a beam of light passing through it and make its path visible. They do not settle down when left undisturbed, that is, a colloid is quite stable. They cannot be separated from the mixture by the process of filtration, but a special technique of separation, known as centrifugation, can be used to separate the colloidal particles. The components of a colloidal solution are the dispersed phase and the dispersion medium. The solute-like component or the dispersed particles in a colloid form the dispersed phase, and the component in which the dispersed phase is suspended is known as the dispersing medium. Colloids are classified according to the state, solid, liquid or gas, of the dispersing medium and the dispersed phase. Common examples of colloids: dispersed phase, dispersing medium, type, example, liquid, gas, aerosol, fog, clouds, mist. Solid, gas, aerosol, smoke, automobile exhaust. Gas, liquid, foam, shaving cream. Liquid, emulsion, milk, face cream. Solid, liquid, sol, milk of magnesia, mud. Gas, solid, foam, rubber, sponge, pumice. liquid, solid, gel, jelly, cheese, butter. Solid, 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 sol, colored gemstone, milky glass. Separating the components of a mixture. Most of the natural substances are not chemically pure. Different methods of separation are used to get individual components from a mixture. Heterogeneous mixtures can be separated into their respective constituents by simple physical methods like handpicking, sieving, filtration that we use in our day-to-day life. How can we obtain colored component dye from blue-black ink? We find that ink is a mixture of a dye in water. Thus, we can separate the volatile component, solvent, from its non-volatile solute by the method of evaporation. How can we separate cream from milk? Nowadays, we get full cream, toned and double-toned varieties of milk packed in polypacks or tetra packs in the market. These varieties of milk contain different amounts of fat. Sometimes, the solid particles in a liquid are very small and pass through a filter paper. For such particles, the filtration technique cannot be used for separation. Such mixtures are separated by centrifugation. The principle is that the denser particles are forced to the bottom and the lighter particles stay at the top when spun rapidly. Applications: used in diagnostic laboratories for blood and urine tests. Used in dairies and home to separate butter from cream. Used in washing machines to squeeze out water from wet clothes. How can we separate a mixture of two immiscible liquids? We can separate kerosene oil from water using a separating funnel. Applications: to separate mixture of oil and water. In the extraction of iron from its ore, the lighter slag is removed from the top by this method to leave the molten iron at the bottom in the furnace. The principle is that immiscible liquids separate out in layers depending on their densities. How can we separate a mixture of salt and ammonium chloride? Ammonium chloride changes directly from solid to gaseous state on heating. So, to separate such mixtures that contain a sublimable volatile component from a non-sublimable impurity, salt in this case, the sublimation process is used. Some examples of solids which sublime are ammonium chloride, camphor, naphthalene and anthracene. Is the dye in black ink a single color? Take a thin strip of filter paper. Draw a line on it using a pencil, approximately 3 cm above the lower edge. Put a small drop of ink, water-soluble that is, from a sketch pen or fountain pen, at the center of the line. Let it dry. Lower the filter paper into a jar or glass or beaker or test tube containing water so that the drop of ink on the paper is just above the water level, as shown in, and leave it undisturbed. Watch carefully as the water rises up on the filter paper. The ink that we use has water as the solvent and the dye is soluble in it. As the water rises on the filter paper, it takes along with it the dye particles. Usually, a dye is a mixture of 2 or more colors. The colored component that is most soluble in water rises faster, and in this way the colors get separated. This process of separation of components of a mixture is known as chromatography. Chroma in Greek means color. This technique was first used for separation of colors, so this name was given. Chromatography is the technique used for separation of those solutes that dissolve in the same solvent. Applications: to separate colors in a dye, pigments from natural colors, drugs from blood. How can we separate a mixture of two miscible liquids? To separate acetone and water from their mixture, take the mixture in a distillation flask. Fit it with a thermometer. Arrange the apparatus as: heat the mixture slowly, keeping a close watch at the thermometer. The acetone vaporizes, condenses in the condenser and can be collected from the condenser outlet. Water is left behind in the distillation flask. This method is called distillation. It is used for the separation of components of a mixture containing two miscible liquids that boil without decomposition and have sufficient difference in their boiling points. To separate a mixture of 2 or more miscible liquids for which the difference in boiling points is less than 25 K, fractional distillation process is used. For example, for the separation of different gases from air, different fractions from petroleum products, etc. How can we obtain different gases from air? Air is a homogeneous mixture and can be separated into its components by fractional distillation. If we want oxygen gas from air, we have to separate out all other gases present in the air. The air is compressed by increasing the pressure and is then cooled by decreasing the temperature to get liquid air. This liquid air is allowed to warm up slowly in a fractional distillation column, where gases get separated at different heights depending upon their boiling points. How can we obtain pure copper sulphate from an impure sample? Take some, approximately 5 gram, impure sample of copper sulphate in a china dish. Dissolve it in minimum amount of water. Filter the impurities out. Evaporate water from the copper sulphate solution so as to get a saturated solution. Cover the solution with a filter paper and leave it undisturbed at room temperature to cool slowly for a day. You will obtain the crystals of copper sulphate in the china dish. This process is called crystallization. The crystallization method is used to purify solids. For example, the salt we get from seawater can have many impurities in it. To remove these impurities, the process of crystallization is used. Crystallization is a process that separates a pure solid in the form of its crystals from a solution. Applications: purification of salt that we get from seawater, separation of crystals of alum, fitkari from impure samples. Physical and chemical changes. The properties that can be observed and specified like color, hardness, rigidity, fluidity, density, melting point, boiling point, etc. are the physical properties. The interconversion of states is a physical change because these changes occur without a change in composition and no change in the chemical nature of the substance. Although ice, water and water vapor all look different and display different physical properties, they are chemically the same. Both water and cooking oil are liquid, but their chemical characteristics are different. They differ in odor and inflammability. We know that oil burns in air, whereas water extinguishes fire. It is this chemical property of oil that makes it different from water. Burning is a chemical change. During this process, one substance reacts with another to undergo a change in chemical composition. Chemical change brings change in the chemical properties of matter and we get new substances. A chemical change is also called a chemical reaction. What are the types of pure substances? On the basis of their chemical composition, substances can be classified either as elements or compounds. Elements. Robert Boyle was the first scientist to use the term element in 1661. Antoine-Laure Lavoisier, 1743-94, a French chemist, was the first to establish an experimentally useful definition of an element. He defined an element as a basic form of matter that cannot be broken down into simpler substances' chemical reactions. Elements can be normally divided in metals, non-metals, and metalloids. Metals usually show some or all of these properties. They have a luster, shine. They have silvery grey or golden yellow color. They conduct heat and electricity. They are ductile, can be drawn into wires. They are malleable, can be hammered into thin sheets. They are sonorous, make a ringing sound when hit. Examples of metals are gold, silver, copper, iron, sodium, potassium, etc. Mercury is the only metal that is liquid at room temperature. Non-metals usually show some or all of these properties. They display a variety of colors. They are poor conductors of heat and electricity. They are not lustrous, sonorous, malleable. Examples of non-metals are hydrogen, oxygen, iodine, carbon, coal, coke, bromine, chlorine, etc. Some elements have intermediate properties between those metals and non-metals. They are called metalloids. Examples are boron, silicon, germanium, etc. Compounds. A compound is a substance composed of two or more elements, chemically combined with one another in a fixed proportion. Mixtures and compounds. Mixtures. 1. Elements or compounds just mix together to form a mixture and no new compound is formed. 2. A mixture has a variable composition. 3. A mixture shows the properties of the constituent substances. 4. The constituents can be separated fairly easily by physical methods. Compounds. 1. Elements react to form new compounds. 2. The composition of each new substance is always fixed. 3. The new substance has totally different properties. 4. The constituents can be separated only by chemical or electrochemical reactions.